All right, so let's go ahead and solve a non-inverting amplifier example. And I'm gonna go ahead and draw it a little bit differently just so that you can get used to seeing a couple different ways this thing can be drawn, but it is the exact same circuit. I'm gonna just draw it this way. This is another way to draw the same circuit that we saw in the previous slide, where this is V out, obviously. I've got my input signal connected to the plus terminal, and my feedback network is connected as such. I'm going to go ahead and call this a 2K resistor and a 10K resistor, and let's go ahead and put a 3-volt source here, and let's go ahead and solve this circuit. Okay, we're going to go ahead and solve it the long way, and then we'll go through and solve it using the equation from the previous slides and just show that they are equivalent. Okay, so let's go ahead and start. I know that I have 0 volts here, so my voltage drop across my battery, 0 volts here, so my voltage drop across my battery is 3 volts. I know that I'm going to have 3 volts at my plus terminal. Since I have 3 volts at my plus terminal, I know that I have to have 3 volts at my minus terminal. And I also know that I'm going to have no current flowing into my minus terminal. This current here, or this current here, is 0. And so all the current that flows through this 10K is also going to flow through this 2K. None of it is going to go this way. So let's call this one I1, and we'll call this one I2. And I'm going to go ahead and make my KCL equation here. I1 is equal to I2. My expression for I1 is going to be 3 volts minus 0 volts divided by 2K, right? That's going to be the voltage drop across this resistor divided by this resistance. I2 is going to be, let's see, it's going to be V out minus 3 volts divided by 10K. All right, and so we can set those two things equal. Let's just to clarify, this is coming from V out on the plus side, 3 volts on the minus side, divided by 10K. Okay, so we set those equal. I get 3 volts divided by 2K is equal to V out minus 3 volts divided by 10K. So what I can do is I can actually multiply both sides by 10K and then add 3 volts. And I get V out is equal to 3 volts times 10K over 2K plus 3 volts. And that is V out is equal to 3 volts times 5. The K's cancel, 10 over 2 is 5, plus 3 volts. V out is going to be 15 plus 3, or 18 volts. All right. Hopefully no issues there. And now let's go back and we'll pull in our equation. Go ahead and do that. And let's use this and see how it comes out. I want to evaluate this equation with an input voltage of 3, a feedback resistor of 10K, and an R1 of 2K. And I get V out is equal to 3 volts times 1 plus RF over R1, which is 10K over 2K. The K's cancel. I get V out is equal to 3 volts times 1 plus 5, or 6. So I get that V out is equal to 3 volts times 6, which is 18 volts. Okay, and so we can see that these two answers agree with one another, right? So that's our non-inverting amplifier example. And like I said, I'm going to get into now a special case for the non-inverting amplifier, which is a very useful circuit. It's used all kinds of places in robotics and in signal conditioning and sensor readings. Very useful circuit. And so it's also used in filters. And so we're going to get into that one in the next video. It's very simple. Again, it's just a special case of this non-inverting amplifier topology. All right, so without any further delay, I'm going to go ahead and end this video.